Hello everyone, today I'll be talking about steganography. I'll be explaining what it is and how can we use it. In this presentation, I'll be talking about the history and origin of steganography. I'll also tell you the difference between steganography and cryptography. I'll be showing different kinds and techniques of steganography, and I'll be giving examples. Lastly, I'll be talking about the use of steganography. By the end of this video, I hope that you'll learn about the history of steganography and ways you can do steganography, and why would you use it. Steganography is a way of concealing a certain message, file, image, and even a video within another message, file, image, or a video. If you're going to ask if there's any difference between cryptography and steganography, the answer is yes. The difference between cryptography and steganography is that cryptography is when everybody knows that there's a message, but they do not know the message, so they need to decode it. But in steganography, it is when you try to hide the fact that there's actually a hidden message in it. The word steganography came from the Latin word steganographia, which is a combination of the Greek word steganos, meaning covered or concealed, and graphia, meaning writing. The first recorded use of the term was in 1499 when a German polymath named Johannes Trithemius made a book titled Steganographia, which was first thought to be about magic, but apparently turned out to be a decryption key for his first two books. So here are the different techniques or kinds of steganography, and I'll be giving you guys an example later on. Text steganography is hiding a message inside a text. You can change the format or words within the text in order to make the hidden message within the message. Here is an example for text steganography. If you haven't noticed it yet, I'll give you some time to find it. If you notice, some letters have shadow effects on it. If you add all those letters, you will come up with the word sample here. Image steganography, specifically digital, have a huge number of bits present in it, and we can hide the message there using those bits. I'll show you a video explaining it more. If you want to watch the whole video, I'll leave the link below.
So cryptography is the idea of encrypting a message so that although everyone knows the message has been sent, they can't actually find out what it means. Whereas in steganography, we're trying to hide the fact that we sent a message at all. So a classic example would be if I was writing you a letter and then I wrote in invisible ink a whole different letter between the lines or on the other side or something like that. And only you knew that that was going to be there. So you get home and everyone else maybe looks at the letter and thinks, that's just not very interesting at all. And then of course you can uncover the secret message. Today we'll talk a bit about digital image steganography, because obviously there's a huge scope for hiding things in digital images. Images can be megabytes or more, and you can hide files of megabytes or more in them. But of course, as the amount of steganography in images has increased, so has the attempts to try and find it. So there's lots of statistical approaches to try and find these things as well. Perhaps the most simple form of steganography in an image is least significant bit steganography. So if we've got a bitmap of any kind, a PNG or a BMP, then we can change the lowest bits to be our message, and it'll have an almost imperceptible change on the actual way the image looks.
It's a bit like if I change the number 800,351, if I change the 1 or the 51 on that, it's not going to have a massive impact.
That's exactly right. But the number is so big that in the grand scheme of things it makes no difference. So generally speaking, we'll change in the image for every single byte, we'll change the last bit, or maybe the last 2 bits if we're really trying to cram in a lot of data. Every byte is 8 bits. We take the last 2 and change that to our message in the hope that no one's going to notice. So for every byte, that's every 8 bits, 6 of them are the regular image and 2 of them are our secret message. So a quarter of our message is now secret. So if we have a normal pixel, it's going to be 4 bytes long. So that's 1 byte. So for each byte, we're talking about the last 2 bits in that byte. So that could be a 1, we could change it to a 1, change it to a 0, or leave them both the same. And what we do is we read off our message. So let's say our message we're trying to encrypt is 101101. Okay, we get to the first byte and we say, well, this is great. Our first 2 bytes are already 1 and 0, so we don't need to change anything at all. So that byte stays as it is. So we go to the next byte. So this will be maybe be red and this might be green in our pixel. Okay, the last 2 bits of this byte are 0 and 1. The 2 we're trying to put in from our message are 1 and 1. So we change this one to a 1. So by changing that second least significant bit from 0 to 1, we've just increased this value by 2. And we're talking about one channel in a huge image changing by 2 levels. It's probably not going to be too noticeable. If we start changing the higher significance bits, then that might be a problem. Alright, so I've written a program to do this, and I've tried to hide a rather large file inside another rather large image. Okay, so this is a nice picture of a tree. It's about 3 and a bit megapixels in size. So this is the original image of our tree, and that's the steganographic image. First one, and to the second one.
But it's not changing.
It is changing. When you only change the last 2 significant bits of an 8 bits per channel image, you're not going to see a huge amount of detail. If you actually do a subtraction on the images, you can see a difference. But in general, it's going to be pretty imperceptible. But the really good thing to do would be to never release the original source image. I can tell that something's changed because I've got the original and the new steganographic image with me. But if I just sent out an image of my dog and I never sent out the original but the camera took, no one's going to know that it's been imperceptibly changed because they haven't got a reference.
In audio steganography, the message is embedded into the signal of the audio, which alters the binary sequence of the certain audio file. I'll show you a video on how to notice or decode the audio steganography.
Somebody would have to know where to look and that there's a secret message in that file to extract it. The tool we're going to use to extract the secret message or to visualize the secret message is Sonic Visualizer. So let's open this. With Sonic Visualizer, we're going to open the WAV file. Go to File, Open. Let's browse to ironmaiden.wave. Click on that. Click on Open. And it just opens it normally here. I'm scrolling with my mouse ball up so you can expand this. If we click on Play, it's going to sound like normal. So what we have to do to reveal the hidden message is to look at the spectrograph. So go up here to Layer, and then we're going to select Add Spectrograph. We'll do both channels because we have stereo, channel 1 and 2. Click on that. And now that you see the spectrograph, you can see the hidden message right here. Run to the hills. So this is a way to create a message and then hide that message inside an audio file. There's really a lot of ways to hide data using steganography. This is just one example. The reason we would use steganography as opposed to cryptography is with steganography, we don't give any indication that we have hidden data. It's hidden in plain sight. Whereas with cryptography, the data is encrypted, so someone would know that there's some secret message there. Steganography is supposed to be hidden in plain sight.
Video steganography can be a combination of both image and audio steganography. I'll show you a video on how this prisoner of war sent a message while he was being filmed using Morse code.
How do you are treated in the camp?
I get adequate food and adequate clothing and medical care when I require it.
How do you think about what's so-called?
As you can see on the video, Admiral Jeremiah Denton, a prisoner of war in the Vietnam War, was told to answer questions about their living conditions, and he was told to lie or he will be punished. While answering, you can see he's blinking his eyes to send a Morse code that says torture. Steganography can be used by the soldiers to send messages that their enemy can't detect or notice. It can also be used to simply send a message that you want nobody else to know. You can also use it to just keep a message hidden. In summary, steganography is a way you hide a message without anyone noticing it. And the difference between it and cryptography is that cryptography can have a noticeable message. There are different kinds of steganography, and we can use it in different ways in any way we like. And that's the end of the video. If you want to watch the remaining parts of the videos I shared, I'll share the link in the credits. Thank you guys for watching. I hope that you learned a lot. Until next time.